So I've referred to this mysterious .NET framework many times already throughout this series, and it's time, finally, to tackle what the .NET framework is, at least from a high level. And as I'm going to conclude at the end of this video, while it's good to understand the basics, you're going to get diminishing returns from investing a lot of time in trying to understand how everything works under the hood. As the old saying goes, you don't want to see how the sausage is made, but it's sometimes helpful to at least know what the ingredients are. So whenever you learn how to write applications using any programming language, in our case C#, learning the syntax of C#, in other words, the nouns and the verbs and the punctuation of the programming language, is just half of the battle. The other half of the battle is learning about the related pre-built functionality that's available to the programming language. So in our case, in the Microsoft world, Microsoft created something called the .NET Framework. And while that kind of sounds mysterious and ominous, it's actually not all that bad. There's really just two parts of the .NET Framework that concern us. First, we're going to talk about the class library. And the class library is simply a library of code that Microsoft wrote to take care of different tasks, difficult tasks, so that we as developers don't have to worry about these sorts of things. So there's library code to help with math operations and working with text, like the string builder class, with displaying things to the computer screen, like we've been using with the ASP.NET API, transmitting information over the internet through web services. There's library functions for data access and for security and for performance using multi-threaded APIs and a lot more. So the class library is actually known by a couple of different names. It's called the class library, but it's also called the framework class library, or the FCL, as you'll see it in print, or the base class library, or the BCL. So whenever we're referring to the FCL or the BCL, we're talking about the entire framework as a whole. However, we typically only work with a small portion of all of the classes in the framework class library. It's kind of like a big corporation with a lot of departments. The first floor might be accounting, the second floor is for marketing, the third floor is for IT, and so on. You might only go to work and use a certain amount of the facilities based on your job role, your function. All right. So the .NET Framework class library is also broken up into sections based on the job that particular area of the API is trying to perform. So for example, whenever we're working with ASP.NET related classes, we're working within a part of the .NET Framework called system.web, or rather the system.web namespace. And it contains hundreds, if not thousands of classes that are related to ASP.NET Web Forms, ASP.NET MVC, and their shared functionality. So we've not used much of the ASP.NET API, the application programming interface, that section of the .NET Framework class library that deals with ASP.NET just yet, but we will whenever we talk about the ASP.NET Web Forms in that specific series. All right. So you can see where these libraries are stored on your own hard drive. And again, this is just really for academic purposes, but it might be interesting to look at how the library is split up into multiple files. So let's go to the c:/windows/microsoft.net/framework/ and then we'll just go to the v4 030319 version. And if you were to scroll down, there's just a ton of tools. So they have a .exe file extension, and then also if we scroll down far enough, we start seeing that there's a number of Microsoft.something.dll. And if we scroll down even further, there's a lot of these system.collections.dll, which we're going to use in a little bit here. But if you scroll down far enough, you're going to find the system.web DLL, all right? And you can see that there's one little issue with the system.web.dll that I'm going to point out here, and it's a cause of consternation currently within Microsoft as they're trying to rewrite ASP.NET MVC functionality. You can see that DLL is 5 megs, 5 5,321 KB. All right, so that gets loaded every time into memory whenever you are accessing a web page or whenever your users are. And if there's multiple people hitting your website at the exact same time, that DLL is getting loaded every time into its own context. Execution context. And so this can cause performance issues on web servers, and that's why they need a lot of RAM. Just wanted to point that out, that DLL file contains thousands of classes of code that's been compiled into this large file and accessible to us as our applications run as they're executing in that fraction of a second to create a web page. Okay. All right. And if you take a look at some of the utilities too, there's some interesting things here. If we go up to the top here, here's the csc.exe. This is the C# command line compiler, and you can use Notepad to write your C# and then use the csc.exe to compile your Notepad files into a .NET assembly, which contains, as we'll talk about in just a moment, all the code that you wrote in a compiled format. All right, and Visual Studio farms out the operation of C# compilation to this command line tool as well. And so I'm just kind of showing you these things, not because it pertains to the topic at hand, but just because we're here and thinking about it. Okay, so I said there's two parts to the .NET framework. The first part is the base class library, framework class library, whatever you want to call it. The second part of the .NET framework is what I've been referring to as the runtime, also known as the Common Language Runtime, or the CLR. And you can think of it like as a protective bubble that wraps around your application. Your application lives inside of this little ecosystem that's created by the Common Language Runtime. And so when I use this term ecosystem or protective bubble, I mean that the CLR takes care of a lot of the low-level details so that you, the developer, can focus on what the application does and less about how to interact with the computer's operating system, how to access the file system, how to create new objects in memory and things of that nature, what hardware is it running on, and so on. You're protected from all that from the .NET Framework runtime, or the Common Language Runtime, the CLR. Furthermore, the CLR provides a layer of protection for the end user, not so much in web applications, but mostly in desktop applications, so that you, the malicious, evil software developer, you can't do much harm to the end user's computer, at least not without their approval. Certain features and functions like deleting things will require administrative approval in the operating system. It'll pop up a little message box and alert the user to the fact that they're going to make a major change to their operating system. So you can't really do anything without at least calling it to their attention that your intent is to manipulate some part of the system, and you could be malicious. So the CLR, or rather the runtime, is sometimes referred to as an application virtual machine. And it's similar to the Java virtual machine, or the JVM if you're coming from Java. It manages memory using a garbage collector. It manages security. It manages exception handling. So whatever happens whenever an error occurs in your application and you, the developer, did not handle the situation, the .NET Framework Runtime, the CLR, pops in and it takes care of the situation. And like I said before, there are other parts of the .NET Framework as well. We talked about the compiler. And I want to talk about what the compiler does for just a moment. The compiler creates .NET assemblies, which are filled with Microsoft Intermediate Language, or MSIL. It's often just called IL, Intermediate Language. And it stores that intermediate language into either a .exe file or a .dll file. So for reasons that go back like 25 years, .exe means that the assembly can be executed. There's a predefined entry point, and when the user clicks either an icon on their desktop, that's essentially a shortcut to an executable application that will then launch. There's also the DLL. It stands for Dynamic Linked Library, but it's kind of been repurposed and reused. It doesn't have any of the same connotation that it did originally, other than the fact that it's a library of code that can be used. And it Basically, a DLL means that the file contains code to be used as a library of functionality, typically used by another assembly like a .exe. Or in our case, it's used by a web application that runs in the context of an additional execution environment that's called the ASP.NET Runtime. So the ASP.NET Runtime is kind of like the CLR, it just has a different purpose. It bridges the gap between the code that you write and the web server that the code is hosted on, and usually that's Internet Information Services. So it too provides services related to memory. It provides a lifecycle that you, the developer, can plug into. So that's what the page load ultimately really is. It's just us plugging into an event that's raised by the ASP.NET Runtime at a specific moment in the lifecycle of a web page request. Let's focus on the fact that our application is compiled twice. The very first time that you attempt to run the application or the assembly on a new machine, the .NET Framework Runtime performs a second compilation on that MSIL version of the assembly, the .exe or the .dll. What it does during that second compilation process, it really depends on the hardware and the software that your system is using, and it'll create an optimized version of your assembly for that particular configuration. And so just to show you the intermediate language and what it looks like kind of under the hood, what you can do is use this program called ILDASM. And I'll go ahead and launch it from my toolbar. I made a shortcut to it because it's kind of hard to find. You have to go to your local disk, Program Files, x86 if you're on a 64-bit machine, Microsoft SDKs, where are you? There you are. Windows, and then just pick a version of Windows. I picked the final one, V81A, and then go into the bin directory, and then the netfx 451 tools, and then there's just a bunch of tools in here, and one of them is ILDASM, and that stands for the Intermediate Language Disassembler. So there's an ILASM, which assembles your code in intermediate language, and then ILDASM is a tool that allows you to see what was generated. There's also commercial third-party disassemblers that allow you to take somebody else's application that they wrote and disassemble it, and so you can actually then write C# or Visual Basic again and modify the application. So what happens in that case is that if you're really concerned about the security of your application, you don't want somebody else to have your source code, you don't want somebody else to decompile your source code, what you can do is run your app through an obfuscator, another type of application. It's kind of like an arms race, a cat and mouse chase, where one side figures out how to obfuscate the code, the other side determines how to de-obfuscate the code and disassemble the application into source code that can be manipulated by a developer. All right, but just to kind of show how ILDASM works, let's take a look at, let's go File Open, and take a look at our projects. Let's go to that Challenge Casino Helper Methods solution, and we'll just drill into the bin directory. And bin stands for binary. It's where your intermediate language assemblies are placed when you do the compilation step. When you do Internet Explorer run, it creates the IL version of your assembly and it stores it here, and then there's another just-in-time compilation step where it creates another version of your assembly in machine language specific to, again, the hardware and software that you're running right now on your computer. We're not privy to see those files. They're not easily or accessible or even accessible at all. However, we can see the intermediate language that was generated, and it's not all that exciting, but you will see some common things that will will remind you of the application that we wrote. So you can see here that there's the namespace itself, then the class name, and then all of the objects that belong to the class. So for example, the money label is an instance of system.web.ui.webcontrols.label. So that label is the class, and we created an instance of that class called money label. All right, and then here are the methods that we wrote or that we handled. So for example, the page load, if we were to double click this, what we would see is a bunch of code that means absolutely nothing to us. Occasionally a word will pop out, and if we looked hard enough, we could see state bag, so that's probably dealing with view state. Here's a call to a display player's money method, but for the most part, this is code that doesn't make a whole lot of sense to us. It really provides a layer of abstraction so that any .NET programming language, whether it's Visual Basic or Iron Python or C# or F#, that they can all compile down to the same intermediate language. And so really at the end of the day, it doesn't really matter what language you use because they all output the same result, which is an assembly that contains intermediate language code, which is then again just-in-time compiled or JITted, J-I-T-T-E-D, JITted into an assembly that's actually being used by the computer itself, and it's been optimized for that specific computer that it's running on. Okay, so let me wrap up by saying that the reason that I wanted to talk about the .NET Framework Class Library and the .NET Framework Runtime right now is because it really depends which side of the curriculum you're going to go down. But if you're going to take a tools-driven approach, you're going to need to at least know how to work with classes and namespaces because you're going to be working with the .NET Framework Class Library. You can't get away from classes. However, you're probably not going to create your own custom classes. That would really lend itself to the other leg of our curriculum, which is the maintenance-based curriculum, okay? Where you're creating custom classes like we did in the previous lessons, and those represent domain objects in the system, and they interact with each other to solve software problems. If you're taking the tools-based approach, you're relying on Visual Studio's tools and wizards and editors and to generate code for you. And your main exposure to classes will be accessing the .NET Framework Class Library to get at that functionality. So you at least have to know how to create new instances of objects, what happens in memory whenever you create new instances. You're going to be creating assemblies no matter what, and how are those being utilized within, on the computer, how are they being loaded, what's the purpose of the framework, runtime, and so on. Okay, so that's why I wanted to talk about that now. All right, so that wraps up this lesson. We're going to continue talking about classes and things you need to know at a baseline level, not deep into object-oriented programming, but just at a base level so that you can work with the, at a minimum, the BCL, the FCL, whatever you want to call it, okay? So we're going to continue with this in the next lesson. We'll see you there. Thanks.